Alright, welcome back. This is our second recording for Chapter 2. Today we're going to talk about sections 2.4 and 2.5 combined. They're both pretty short, so we're just going to go over kind of the basics. 2.4 is all about chemical reactions. Chemical reactions are essential for life. We have to have molecules getting created and getting broken down in order for life to exist. So some basics on chemical reactions are that we always start with reactants. This is what goes into a chemical reaction. And we end with the product. So the chemical reaction is simply going to be the process of making or breaking a chemical bond. So in this image you can see we've got some hydrogens, and we're going to add those together with some oxygen. So this is the reactants. These are the guys that are going in. The arrow signifies a chemical reaction has occurred, and what comes out are two water molecules. So we've got 4 little white hydrogens. We still have 4 white hydrogens here. 2 red oxygens. We still have 2 red oxygens in the end. So the reactants become the products. For any chemical reaction to occur, we have to have some energy go in. It varies. Different reactions require different amounts. This is called activation energy. This is the energy needed to activate the chemical reaction, of course. So in order for this ball to roll down the hill, we have to put some energy in to get it to the top. Is basically all activation energy is about. So we have 2 different kinds of reactions. We've got endothermic and exothermic. Endothermic reactions are where more energy is going to be used to start the reaction than we end up with the product. An exothermic reaction is just the opposite, where you end up with more reaction or with more energy. I'll show you an example of an exothermic reaction in class with liver and hydrogen peroxide. 2.5 is all about enzymes. Enzymes are crucial for our complex bodies to function. We have to have some molecule, some structure that can make a chemical reaction occur fast and efficiently. So enzymes, they're pretty much always going to be proteins, but they are a catalyst. A catalyst, remember, is a molecule or a substance that decreases the activation energy needed to start the chemical reaction. So they lower the amount of energy needed to make something happen. They also make things happen faster. They make our chemical reactions occur at a rate that allows complex life to exist. So in this diagram, and you shouldn't be surprised to see this on the test, so I'd be familiar with this, we have energy increasing on the vertical axis, and we have time going across the horizontal axis. So as the reaction progresses, we have to put energy in before anything really happens. And with an uncatalyzed reaction, uncatalyzed means there's no enzyme involved, the activation energy needed to be put into the reaction is up to here. Then the reaction occurs and energy comes back out, and we end up with the products. If we put an enzyme in the mix, we start with the same reactants. We still have to put activation energy in, but in a catalyzed reaction, one that is using an enzyme, less activation energy is needed before the reaction begins, and we end with the same product. So this is your basic activation energy diagram. Like I said, enzymes are generally proteins, which makes sense because proteins are shape-based molecules. Enzymes function in that same manner. They have a very particular shape that allows them to do whatever job they're needed for. So let's say this enzyme right here is going to take the 2 reactants, the substrates. The reactants will each bond with the enzyme in very specific locations. This is how the enzyme works. The fact that this enzyme can hold on to this molecule and hold on to this molecule at the same time, it all comes together as a unit. The enzyme facilitates the bonding right here. It basically causes these 2 reactants to bond together to become the product. So now we have a different molecule than what we started with. The enzyme is still there. It's still ready to take 2 new substrates and do the whole process over again. These substrates are going to bond to very specifically structured sites. These are called the active sites. Every enzyme has a particular shape, and that shape determines what substrates it can bond with. If the enzyme doesn't have the right shape, then it's not able to do its job and it doesn't function properly. All right, that's it. That's the end. This was a very short section, 2.4 and 2.5.